Welcome everyone to our special webinar today. I'm thrilled to have you join us as we dive into some of the most important topic on Android, I think, in modern Android development, because today we are going to explore architecture. So plan for today is that we'll explore the challenges that Android developers face in today's fast evolving tech landscape. We will talk about best practices, or rather good practices, I like to call them, for architecture in 2024 and beyond, ensuring that you're ahead of the curve in designing robust, scalable apps. We'll kick off the third cohort of the Android architect. It will be an opportunity to elevate further your skills and career with our course. And of course, in the end, we'll wrap up with a Q&A session when I'll answer your burning questions and share some insights from my experience. Because I think those Q&A session is the best element of every webinar. Yeah, before we dive in, please allow me to introduce myself. I work in Android since 2016, and I'm proud to be recognized as Kotlin Google Developer Expert. This is title awarded by Google for those who know something about the technology and give back to the community. And beyond that usual software development work, I've dedicated myself to helping clients navigate in complexities of legacy projects, transforming outdated code bases into more modern, efficient applications. And you maybe saw some of my talks on DroidCons, DevFest, or you recognize me from my social media content on LinkedIn, on Twitter. And I founded Android Pro with a mission to empower Android community with the knowledge and skills so the Android developers will excel in the careers. So my journey with Android at my first job, we didn't really use any design patterns. And we wrote everything in plain Java. Eventually, we introduced Model View Presenter. We introduced Kotlin when it was announced as a language Android developers can use. As I moved to my next role, I brought some skills with me, helping agency clients develop more organized architecture. And then there was a work with Model View Intent, clean architecture, things like that. And eventually my path led me to startup product company where I was part of a team that developed solid development processes and actually embraced clean architecture at its core. And we even experimentally introduced Kotlin multi-platform mobile in 2020, pushing the boundaries of what was possible at the moment and opening up new possibilities. And in my current role, I work more as a consultant, guiding Android teams as they navigate through this ever-changing ecosystem of mobile development. And in the last years of my work as a consultant, I saw some real weird projects. And I began to understand that even great engineers fail very often when it comes to building apps that are not only eye-pleasant, but also well-designed and maintainable. So I distilled core problems that Android teams face when working on their application. It's ever-changing ecosystem. It's following every single recommendation from Google. It's other thing is ignoring all the recommendation, building everything on our own, reinventing the wheel. And the fifth core problem is that some recommendation doesn't really make sense. So let's start with the first problem. Back in my early days, staying updated with Google recommendations was manageable. However, as the platform is evolving, oh, someone is calling me, sorry. As the platform is evolving, the updates started coming in every few months. So You may be refactored from Eric's Java to Kotlin coroutines, from Java to Kotlin, from data binding to vbinding. Well, we have new thing every few months. And it's good that Google is pushing new stuff, but it feels like running a never-ending race trying to keep up with what they're doing while we have to balance the project deadlines. So how the problem appears? Those updates are very rapid. The pace of those updates is very rapid, and it can make it challenging for developers to keep apps aligned with the latest recommendation. And this often leads to mismatch between our current app architecture and new standards proposed by Google. So how to overcome this? The key is to adopt some kind of modular approach to app development, and it doesn't necessarily mean feature modules or gradual modules. Modular approach to our projects. Some kind of solution that will allow us to update specific parts of our system without complete overhaul. And additionally, we should think about prioritizing updates that offer significant benefits in terms of, first of all, security, the second thing in performance, and third, maintenance. So we as Android developers could manage our resources effectively. So like it or not, continuous learning is a must, and flexible architecture helps a lot. Other thing is with following every recommendation, and this is problem. Let me explain. On one of the teams I worked with, we faced the task of rewriting an app to follow the latest recommendation. So the app, legacy project filled with tens of years of code, needed a modern touch. While everyone was on board with this idea of rewriting the app, the actual process was overwhelming. We had to weigh the benefits of adopting new practices against the time and resources we actually have. So we needed to plan how to rewrite major parts of the application. So it was a battle between innovation and practicality. And how that kind of problems appear. So rewriting an app to follow the latest recommendation can be daunting task, especially for old, large legacy code bases. And this process is resource intensive and risky, potentially introducing new unexpected bugs, eventually disrupting user experience. Think about permission systems that change like every 2 Android updates. So how to face this challenge? We cannot leave legacy code as it is. So incremental refactoring is often more practical than a full rewrite. And we need to identify and update critical parts of our application gradually over time. And this will minimize the risk of this refactor and possibly make the process more manageable. So we need to leverage automated testing, some other analysis tools, refactoring tools. So it will help us ensure that updates do not negatively impact app functionality. And now my favorite, not following Google recommendation at all. So last year, I've consulted for a team where the decision was made to completely ignore most of Google recommendations. The team didn't even wanted to use Kotlin. And the reasoning behind this was that we have resource constraints, we need to develop features. And in the team, there was the belief that the current solution is good enough. However, this approach led to huge technical debt piling up. making future updates and maintenance a nightmare. So in one case, the team struggled to implement a feature that would have been straightforward if they had followed Google architectural guidelines. It was, I believe, connected to navigation and deep linking. So probably the cost of catching up later outweighed the initial savings on development. And how that kind of problem appears. So team may choose to ignore some recommendations due to resource constraints or to believe that current solution is enough. However, over time, this can lead to increased technical debt, making future updates more challenging and time-consuming. So how to face that kind of challenge? We need to regularly review and assess potential impact of every new recommendation. So we will make an informed decision about which updates to implement. We can also establish a technical debt backlog and allocate some time in our work for periodic refactoring that could possibly mitigate long-term risk. And engaging with the wider Android development community can also provide some insights and strategies for effectively adopting new practices. Not invented here. There should be a wheel emoji. Sorry, you cannot see that probably. But this is a problem connected to reinventing the wheel. Sometime before the COVID-19, I was part of a team that took pride in building everything from scratch. We had our custom dependency injection library, we had our own annotation processor, you name it. I hope, Raju, you are listening to us because this slide is for you. And this not invented here syndrome was initially seen as a way to showcase our engineering skills. However, as the project grew, so did the realization that the time we were losing on reinventing the wheel, we were losing time instead of focusing on developing some unique features. And it was a hard lesson. It was hard lesson for us because we didn't want to leverage existing solution to introduce some third-party library. And how the problem appeared? Well, there was a desire to build custom solution for problems already solved by existing libraries or frameworks. And we introduced unnecessary complexity and wasted a lot of hours of developers' time. And this not invented here syndrome often stems from a lack of awareness of available tools or from the perspective of we can do it better. So how to face that kind of challenge? We need to foster a culture of research and exploration within the development team to identify existing solutions that can meet our project needs. We need to regularly conduct technology reviews and encourage participation in conferences, developer communities, so the team will be aware of which tools are at our disposal and what are some best practices, what are other people in developer communities using. So somehow we need to implement a decision-making framework for when to build versus when to use some kind of existing solution. And the last problem, I talk about it very often on social media, that some recommendation from Google doesn't really make sense. This is a screenshot from recommended architecture on Android developers page. And they say that, well, we need to implement clean architecture. Okay, but then they talk about that the domain layer is optional layer. And when we are thinking in terms of clean architecture, the domain layer is not an optional layer. We don't introduce domain layer for reusability sake, but to describe our app behavior in pure Kotlin without any other Android dependency. So perfectly, this domain layer could be reused between Android, iOS, in some cases with other front-end platforms, and eventually this could be shared as an Kotlin multi-platform mobile module. Okay, we talked about problems, but what about solutions? So every recommendation we see, every article we read from some big tech company engineering blog has its perks, okay? But most of solutions are not universal. What works for Uber may not necessarily work for our small startup. And what works in, for example, Spotify may not be suitable for banking application. So let's talk about best practices for app architecture, or I'd rather say good practices, not best practices, because there are no single best in software development. It always depends. So first, one foundational practice in modern Android development is adopting some kind of MVX pattern, such as MVVM or MVI, and those are especially suitable when we are working with Jetpack Compose. So these patterns help us in separating the view logic from the business logic, making our code more stable, maintainable. And yeah, MVVM aligns naturally with Compose reactive paradigm, while MVI enhances state modeling, treating states and updates always as immutable, leading to more code, but more predictable and possibly bug-resistant UIs. In one of my projects, we initially bypassed using any kind of MVX pattern, and this code was tightly coupled. We had tight coupling between UI and business logic, and eventually there wasn't any cost saving because this made the app difficult to maintain and test. So after a few screens, we transitioned to MVVM and everyone was happy. We saw immediate improvements in code clarity, testability, and without adopting MVVM or MVI, and especially with modern tools like Compose, where we need to think about recomposition as well, developers risk building applications that are challenging to iterate on. Next thing, clean architecture. Structuring your clean architecture layers, I think it's best to do it in separate Gradle modules. We can do that in packages, but when we move our layers into Gradle modules, it not only improves build times, possibly, but also enforces modularity and the coupling of components. So this approach to clean architecture allows individual features of layers to be developed, tested, maintained in isolation. So we enhance scalability of our application, scalability in terms of how many people at once can work on a single app. Early in my career, we kept our code base in a single module. And I think at the time, most of Android teams were doing single modules. But as the project grew, build times, of course, were painfully slow. But the real issue was tight coupling between components. And refactoring it was a daunting task. So we decided to split our architecture into distinct Gradle modules, and it was game changer. It improved our team's ability to work on different features simultaneously. And I think that ignoring this practice can lead to slower development cycles. And yeah, as always, we are thinking about teamwork because software engineering is a team sport. Next thing, mobile DevOps. Automation in integration and delivery is crucial not only for Android development, but for the whole software engineering industry. But when we are working on mobile applications, the goal, I think, is simple. With a single Git push, it triggers a sequence that builds, tests, and prepares a release candidate. And utilizing CI/CD pipelines minimizes manual work, errors that can come from manual work. It will ensure consistent quality and speed up the release process, making our development cycle more efficient. Um, and before automating our CI/CD processes, every release was a nightmare. We need to allocate like 2 hours for one person to do everything by himself, to check manually all errors, of course, do some last minute hotfixes. Still, the person need to do last minute hotfixes, but adopting CI/CD automation is allowing us to focus more on the development side with the confidence that when we push our code to production, it will be automatically tested by the tests we have. That there will be prepared release candidate for testers in our company. And without that kind of automations, teams risk slower release cycles, increased potential for errors, and in general, lack of consistency and quality assurance. Next thing, one of my favorite too, is to create Android agnostic modules, especially this domain layer. So when we are working in clean architecture, we have these clear separations of concerns. So we have entity layer, we have use cases layer, we have interface adapters, controllers, presenters, and then we have frameworks and drivers. So my recommendation for it is to actually follow this dependency rule from clean architecture as proposed by Uncle Bob. And it means that every implementation resides in the outer layer, but we somehow need to communicate between layers via interfaces, for example. So I think it's a very good practice to make Android agnostic modules if we don't actually need any Android dependency. So we can describe our code, our interfaces, our repositories, our services in domain module, and then implement those interfaces in data module, in application module. And the good thing with that approach is that it fits naturally into Kotlin multi-platform mobile. Okay, in KMM, we also have this concept of expect actual, but we don't really need to use expect actual from Kotlin multi-platform when we have good separation of concerns and when we define most of our application in pure Kotlin. The other thing is connected to this is connected to this thing with Kotlin specific modules, no Android modules. So writing use cases. And I believe we should write for consistency even use cases when we are just calling the repository. Because maybe in the future, in this particular use case, we will add some mapping. Maybe in the future, in this particular use case, we will need to merge data from two different services, from user repository and from some other repository, like orders repository. And what are those use cases doing? Well, I like to think about it as a pure, maybe not as a pure, but as a functions known from functional programming. So in and out without any side effects. So we are clearly defining inputs and outputs for our use cases. And when we are calling this use case from the presentation layer, we don't really care that it is using user repository under the hood. So it fits nicely into concepts of clean architecture and modeling our domain layer. And the bonus point, when we have this Android agnostic modules in our application, we can also write our use cases in here, relying on repositories, not direct implementations. So I think it's a very good practice to follow. Next thing. Next thing is to avoid base classes. And while they can seem like a convenient way to share some common functionality, we often see base view model or base activity. I'm happy that we cannot do base composable right now. But yeah, base classes often lead to tight coupling and can hinder the composability of our classes, of our components. So modern Android development favors composition over inheritance, encouraging the use of interfaces or delegation to share functionalities across classes without the drawbacks of deep inheritance hierarchies. So in the same example, instead of base class, we can use extension function. Or we can go one step further and introduce some delegation. And yeah, using base classes for shared functionality seems like a good idea initially. However, as our app is evolving, the inheritance hierarchy becomes complex, leading to inflexible and hard to maintain code. And embracing composition over inheritance simplifies this architecture and makes our code more modular and easier to work with. And over reliance on base classes can lead to inflexible architecture that is just not right. You maybe heard some things about DDD, domain-driven design. It's a high-level framework for thinking about application in terms of business rules and domain logic. And we can introduce some elements of this high-level DDD framework to our application level design. For example, we should adopt ubiquitous language, universal language, focusing on the core domain. So DDD facilitates communication among team members and stakeholders, domain experts, ensuring that app architecture truly reflects the business application aims to serve. So incorporating elements of DDD into our Android project helps align development efforts with business objectives. leading to more valuable and, in fact, to more valuable applications and architecture that is actually serving our business, because that's why we are doing our applications, to serve some parts of business. It could be food ordering, it could be banking application. We always should think about those high-level business requirements. And from my experience, ignoring some of DDD guidelines, principles, leads to disconnect between our software and business needs that we had to somehow address. And once we started applying DDD, we started with event storming session, and then we slowly began refactoring. The alignment between development efforts and business objectives improved significantly. So we built features maybe not faster, but with greater impact. And without DDD, teams may build application that may fail to meet the most critical business needs. And the simplest thing we can introduce from DDD to our application is to use business-related terms in all of our platforms. If we have some kind of invoice in our system, it should be called an invoice on Android, on iOS, on front-end, on back-end, in our CRM system, everywhere. And I think that's the most important rule. And yeah, I believe that developers who understand the complexities of Android development and know that we have no actual best practices, but we have useful patterns. We have some kind of industry standards. Developers who are able to think in terms of high-level design are designing code not only for machines, but for humans too, are good candidates to become senior developers and team leaders in the future. And before we dive into Q&A session, you sent me some questions via the email. Then I am excited to introduce that we are starting the 3rd edition of Android Architect Cohort course. And this course is designed to teach you these essential skills step by step. Alongside with structured lessons, you have access to office hours for personalized guidance, ensuring that you're never left alone on this journey. So as part of this enrollment, you also have exclusive bonuses, including office hours, including additional courses for those time you need to revisit a complex topic, and additional sessions that are recorded. So these resources ensure that you have support throughout your learning journey. And I will share in a minute link where you can read the agenda. We have it structured in 6 weeks, in 6 modules. We talk about software architecture in general first, then we dive into MVX patterns, we talk about clean architecture, we have an introduction to DDD, we talk about mobile DevOps, and eventually about tools for quality. And the regular price of this course is €599. But today I want to share you some bonus materials that come with this 3rd edition of this course. Oh, the fun fact is that I have the same sweater as on this office hours recording. So as a bonus, you get office hours with me when we talk not about the course content, but about Android development in general. And I think that those office hours are the best thing about this course. We have a Discord community when we discuss Android architecture and Android related things. We have every live call recorded, so you can revisit it later. For your convenience, we have templates, cheat sheets, including stuff like what is it called in clean architecture, what is it called in DDD. So it is easier for you to actually learn those things. We have also a library of application audit sessions and product showcases. And also, if you join this cohort of the Android Architect, you get free course update for the upcoming 12 months. The regular price is $5.99, but if you join today, you have 2 additional courses as a bonus if you join today, and those courses dive deeper into topics. They are extending topics we are covering in the core Android architecture program. It is analytics course, and this is a recording of a workshop about testing coroutines. So today you have lower price for the course and 2 bonus courses. You might wonder, is this course for you? Well, the Android Architect is for developers who want to take their skills to the next level and grow into senior, lead, architect roles. If you are there, good for you. You still may learn something from this course. But if you are just starting with Android, you are not even junior Android developer yet, this may be not for you yet. You can join next year. And spaces are limited to 50 seats for this edition to ensure a quality learning experience, because we have this office hours where we discuss your assignments. And 17 seats were already sold during private pre-sale. And another thing is that we have very strong money back guarantee. So how can you know if this course is actually for you? And the short answer is that you can't know actually until you try it. And I understand that committing to such course is a big decision. And it's normal to wonder if it's the right fit for you, if it's the right value. And that's why we offer a 14-day guarantee. And it allows you to experience the course firsthand, risk-free. And within the first 2 weeks, you'll get access to initial modules of the course. And this is a great opportunity to dive into software architecture and MVX patterns, to interact with the community, to start applying what you learn to real project on your job, on your side project. And during this period, if you decide that the course is not for you, no worries, you can request a full refund, no questions asked. You just write an email to me. So if you're ready to transform your Android development career, follow this link, androidpro.io/architect. Click join cohort number 3, and you are good to go. I'll share it on a chat, so it should be easier for you to click or copy paste. Not sure. So in summary, for $3.99, you're getting access to core Android cohort course, to office hours for the 6 weeks, to bonus content, to 2 additional courses at no additional cost, but only if you're among the first 50 people to join this cohort. So I think it would be unreasonable to miss this chance to elevate skills, especially that it's risk-free. So thank you for listening to this part of of our webinar, and now we can proceed to the Q&A session. But please keep in mind that we have like 10 seconds delay between 10 seconds delay between what I see in the comments and what you are writing. I'll get some questions from the emails you sent me and from the form. The first one was, what do you think about MVI, model view intent? So I think that's a great pattern if we are designing reactive components. We have a lot of things going through user input to our output. And model view intent has these concepts of intent, not exactly Android intents, but some kind of intent. And it's working that way that we are gathering those events coming from the UI in a stream, some kind of stream. It could be Eric's Java stream. It could be stream as exposed as Kotlin Flow, and I think it's a great pattern, but not exactly for applications where we are display heavy. When we are user input heavy, it may be a good idea to introduce that kind of pattern. But for my applications, I'd rather using model view model. If you have any questions regarding our today webinar or questions on the course, please share them in a chat. Oh, there was question where the course starts, and of course, yes, by joining today, you get access to materials immediately, to materials like recordings of office hours, additional sessions, but the core sessions are starting on the first Monday of March. I think it will be 4th of March, and we will be exploring next topics week by week. Okay, we have more questions. When to trigger data fetching, VM init function, or call VM in some lifecycle method? Okay, the issue I see with lifecycle method is that lifecycle methods on view models are annotated with some magic annotation, and then we are connecting automatically. We're connecting something to this lifecycle. But let's consider what kind of data fetching we actually need. When we need data fetching, usually we need this data fetching actually on init, just after constructor, because view model is to be kept with outside of this lifecycle. It has data, it has some state of loading, it has some state of there is data ready to display, and something else is observing those data. So unless we are connecting something to animations that are happening in activity or in fragment, in on resume, on pause, I think it will be better to trigger data fetching in ViewModel init. What would you recommend for UI testing and reducing flakiness on CI environments? Thank you, Jesse, for that question. It's a very good question. Currently, in my projects, I am exploring Maestro. Maestro is an automation tool where you create your UI tests in a simple YAML file, and you are describing in very straightforward way, you are describing what is happening in there. And the good thing is that Maestro learned something from Espresso, Appium, and they have built-in support for popular flakiness on UI tests. And other thing is that the tool itself is free, but they are coming with Maestro Cloud when you are executing UI tests on their environment. So currently, I would explore their solution, Maestro, for UI tests, because the tool itself works for me better than Espresso. Which architecture pattern do you recommend in Clean Compose project? Architecture pattern, you mean this architecture pattern for presentation layer, like MVX, MVVM, because that's the only part that is touching Compose. So it will be either MVVM or MVI. For me, MVVM is much simpler. I'm not working on apps where there are a lot of user inputs, and it's easier for me to model what is happening under the hood as a function is calling something from composable. From composable, some function is calling something in the view model. So we have single function call in there. And then this view model X is exposing state flow. So I would recommend starting with MVVM. And if you want to explore MVI patterns further, well, you can do it if it makes sense for you and your team. But start with MVVM because it supports Compose nicely, especially that we have this state holders, mutable state flow, mutable shared flow, and we can actually observe those states from composables, and then this how was it called? And recomposition is happening more efficiently. And similar question, what about Compose? Should we use MVI or MVVM or both of them? And this is unpopular opinion from me. On one screen, you can use MVVM. On other screen, you can use MVI. Unless you create a shitload of base classes and you are forcing yourself to some kind of architecture. So if it makes sense for one screen to use MVI, why not? But MVVM for Compose is a good starting point. What really matters is separating view from the model by some mediator layer. Okay, there's the question, how to get a job as a junior Android dev or intern in the beginning of the career in this market. Well, it's harder than when I started Android development. But even then, there was like 100 people for one internship, and you had to somehow present yourself during the technical interview. I did a lot of student projects, and it helped me a lot when applying to my first company. But yeah, in Poland, I see like 2-3 junior Android developer position per month. I'm not sure where are you from, but companies are currently hiring more senior Android developers. But learning Android is a very good option. Learning Kotlin, because eventually when you master Kotlin, you can transition to Java backend, and on backend they are using Kotlin. Too. Okay, there's question about Android Architect course. Any additional cost, paid accounts for some services, etc.? No. We are relying on platforms that are no additional costs to use. For example, when we are exercising CI/CD services, we are doing this on GitLab, and GitLab comes with free tier to test everything you need. And I think it's also supported in private projects. So no additional costs. For every tool I present you, there is also a free option. For example, I'm presenting a tool for high-level project analysis, CodeScene.io, and it's free for open source projects, but there is a free version from the guy who developed CodeScene.io that is self-hosted. No, not exactly self-hosted, but you can download this tool and run from command line. So no additional costs. And I just got an email that 2 people joined right now. It's Marco and Roman. So good for them. Okay, we have another question. Thank you for your masterclass. Are there any plans to make course exclusively focused on Gradle for mobile devs? Because it's the hardest part. However, there are so few structured informations. Yeah, that's the reason I decided to include Gradle stuff in mobile DevOps, module for this course, because it's too important for mobile devs. Initially, I planned this course on finishing on clean architecture, but I think it's not enough. In this mobile DevOps module, we are working on custom tasks. I am sharing some tips and tricks for working with Gradle, and this is connected to CI/CD topics. But we can check later, maybe some product, maybe some course or ebook with recipes could make sense that will be focused especially on Gradle. Another question, it is connected to Compose and ViewModel. How to properly handle one-time events from ViewModel in composable functions. We use channels in fragments, but what to use with Compose? Well, instead of channels, you can use shared flow. It should work very similarly to channels. So shared flow, and eventually you can create just callback functions that will be executed in a composable lifecycle event like disposable effect or this other effect. there was disposable effect and something else. Oh, and so we are wrapping up right now. I will send you a recording to this event. It will be available till the end of the week. And then it will go to the course materials. So now your task is simple: to go to androidpro.io/architect, to click join cohort number 3, and optionally, if you want your company to finance this course, you can add company details with tax ID and other stuff. The invoice will be sent automatically. And if you want more seats for your company, just send me an email. We will think about some reasonable discount. Thank you very much for being live. I appreciate it. I appreciate that you are spending this evening with me, with Android architecture topics. Thank you very much. You're the best. And see you later, maybe in the course, maybe in some other events. Thank you very much. Bye.